Good morning, guys. I am putting in a new dry charge unit here at the old trailer park. This unit here is leaking profusely. It's been in a previous video with the swirling tool. So we're replacing the outdoor unit. The indoor unit's not in stellar shape, but they want to save that. Probably a job for a year or two from now. We removed the high voltage from the unit. The bad part is it goes straight down into the ground, so if it's not long enough, we might have to add a disconnect or something like that. Because it's buried all the way to the panel, which is only about 8 feet away, but yeah, I probably won't do any excavating today. Making sure our low voltage is off. It is. I don't want to blow the transformer in the old furnace, so I'm going to take the low voltage wiring out, and as soon as our recovery is done, I can take this unit off and set the new one in place. You can see our low voltage wiring right here. This is each one of the designations. We have our white is our W signal to turn the heat strips on and defrost. Our orange is a reversing valve, energized and cooling. Our blue is the common for all of these circuits. Our yellow is our contactor. It'll travel up here to the contactor, energize it. And our red is our 24 volt hot. One thing I always hated about these Goodman units from about, let's see, this one is 04 CPLE 10 SEER 36 10 SEER 3-ton heat pump. One thing I always hated about them is that this true suction port was tucked away in between these two. It was real hard, especially with those of us with large stature. Try to reach in there and get a hose on it in the winter time, or if we're using like the swirling tool and I want to charge through here, or charge through the suction line, put the swirling tool on a true suction. It's kind of a tangled up mess, but they've improved that now, but this was sort of a series that was bad for that sort of thing. We are inside at the Vortex coil now. As you see, it says we have a 76 piston in there, and the Goodman unit comes with a 71, so we're going to loosen this up and take it out and replace it with our Goodman piston, which is in that bag underneath my wrenches there. Basically, we unscrew this nut, we lift these two pieces apart. There's a piston on the inside right there. There's the existing Teflon seal, a little white ring right there. We're going to take that off and replace it as well, along with the new piston. There's our old piston right here and Teflon seal. They come out just for, the piston's not too far off. It's a 76 and we need a 71, but that's far enough off where we can't leave it in there. If it was one difference, I probably wouldn't care very much, but being 76 to 71, that's far enough apart where it's going to make a difference in performance. Alright guys, I think what I'll do is I'll turn my 3/4 copper, maybe come in like this, turn right in like that. Do the same thing with my 3/8. Of course the dryer is going to go bye-bye, because all the Goodman units have dryers inside of them. If you ever have to service one and there's no dryer on the outside, most of them have the dryer on the inside. Sometimes when I work on them, I'll move them out to the outside, but Goodman's one of the few machines that still keep the dryer on the inside. And I think it's just so they can guarantee that the Goodman dealers will use the dryers. I have my copper all bent into position. There's our 3/8, our 3/4, 7/8 service valve, so I just flared it out with the compact swager to fit into it snug. So you can see that. So we're ready to put the nitrogen on it. I'm going to set some nitrogen there, let it flow through, come back through it, empty out. The reason why I'm going to choose the liquid line side, I thought about this for a while, and since the liquid line has less heat on it anyway, it's just safer for the hose and everything, because it takes a few seconds to heat up these joints and braze them, and it takes a little bit longer for the 3/4. I have finished brazing. I have nitrogen going on the system to pressure check. About 50 pounds so far. Take her up to about 150, let her sit for a while, and if she's good, we will go into the vacuum. In the meantime, we can connect some of our electrical wiring and finish some of our other stuff as well as clean up. Lines are all insulated. Thermostat wires run up here. I haven't tied it in yet. We're sitting on 140 pounds of pressure, which is where we've been the whole time. It was basically what was left in that bottle of nitrogen. And we are looking good, so I'm about to put it in a vacuum, and then I can finish up some of the odds and ends. You don't want to forget that inside of your condenser you do have nitrogen and helium as a holding gas, so you need to release that. The cores are out here and here, so I'm just breaking open the service valve so I can let out the rest of that nitrogen. and then we can go ahead and pull a vacuum on the entire system. I decided to go back to core removers, so I purchased a couple of those Appions. I've never owned those, but everybody seems to love them. They're real lightweight. Lightweight, good action on the valves there. So I'm looking forward to seeing how it works. I haven't been doing it this way for a while. I just got kind of sick of the yellow jacket core removers. Maybe these will be the ticket. So I'm going to use these and see how they work, and I'll let you guys know. As well as the Fisher-Price micron gauge. Guys, I ran the vacuum down to around 500 microns, and Goodman's policy is, this is a dry charge, but their R410A policy is run it down to 500. Wait a minute, if it doesn't rise to 1,000, then you're good. It's been about 5 minutes, so we're starting to slow down. See, we have a rise of 26 per minute, so we are good and happy. So in a few minutes, I'm going to disconnect these hoses and charge the system up. We have about, let's see, I think it was like 180 ounces, so about 11 pounds and some change of R22, and then we will be starting things up. Guys, I'm now charging up the system. You see the R22 over there behind me. Charging things up with our charging hose. Icy, nice and comfy. We have about 10 pounds to go in there before I start things up and take it the rest of the way. And we just started out here. I have the Sporlan Smart tool hooked up here. High pressure on the liquid line, low pressure on the common suction. I can continue to put refrigerant into the suction line. We have our liquid line temperature clamp, and then the suction line temperature clamp right here. So we're going to start things up and see how we do. Let it run for about 10 or 15 minutes while I'm continuing to clean. I have about 12 pounds of refrigerant in the machine. I have the Smart tool on it right now. For monitoring the pressures, we're about 221 over 85 with a 26 degree superheat. Our target's around 20 degrees. I'm using the Field Piece wireless technology to broadcast the indoor wet bulb to my meter. And right now we're at 71.4 wet bulb, so it's kind of sticky inside. So everything's coming along good. I'm going to let it run for a few more minutes and see how close we are to target, and we should be about done.